Hello and welcome to Syngenta's presentation on Elasto G5. Here we are, we're going to talk about adjuvants and why they're important and what we can do. And we're going to introduce you to Elasto G5. It is our first adjuvant that we're introducing to the ornamentals market, and we're very excited to talk to you about it today and show you what value we can add. Okay, so let's start with adjuvants. Why are adjuvants important now and going to be increasingly important in the future? Well, usage of crop protection products is going to continue to be limited. We've seen some changes in recent years and we're going to continue to see changes in the future. So it's incredibly important we get the very best out of what we have available to us. The number of products we have will be limited, and the number of applications we have available to us will also be limited. So using adjuvants to get the very best out of them is very important. And the requirements of our end customers, retail chain, they have changing and increasingly demanding requirements. So we need to get more out of everything. So we have a changing world of chemical crop protection products, and good results are going to count for even more as we go forward. So what are the things we need to think about when we're choosing our adjuvant? What are we trying to achieve? Well, we're looking for improved uptake. We want to make sure that everything that gets on that leaf gets taken up, and adjuvants can help us do that. We're looking for retention aids. So we want to make sure as much of that product stays on the leaf where it lands in order to get more active ingredient there. We're looking for improved coverage. When we hit the leaf, we want to spread as wide an area as possible to make it as efficient as possible for it to be taken up by the plant. We want to minimise our runoff risks, so we don't want to see product that's hit the leaf dripping off and landing on the floor. We don't want that to happen for a couple of reasons. One, from an environmental factor and a stewardship factor, it's not good practice. But secondly, if it's on the floor, it's not achieving what we're trying to achieve. We want it to be safe for beneficials. This is really important because as we move into this new world for chemical crop protection, beneficials play an increasing role. So it's very important that adjuvants are safe for beneficials and safe for biological products. And phytotoxicity risks. This is critical. It doesn't matter if it does all of those. If it damages your plant to a point where you cannot sell it, then it is no use. So these are all things that we need to look into and understand. So what is Elasto G5? This is our new adjuvant. This is the product we're here to talk about. Elasto G5 is an adjuvant based on polyglycerol and coconut fatty acids. It promotes the wetting of the leaf surface, it improves foliar uptake of an active ingredient, it helps improve retention, it helps improve coverage, and it is green chemistry. It is a crop-friendly product and can be used in many ornamental situations. Okay, well, let's start looking at some coverage and retention. Effects of adjuvants on coverage. We've got some lovely images here. The great thing about using adjuvants is you can really show the benefits. And these are some images from Lisianthus at 600 litres a hectare. And what we've done is we have mixed a lot of these products in these images with fluorescent markers and then put them under black lights to show off what we are doing. And you can see from the first set of images there, let's see if I can highlight them. There we go. In these images here, we have got water and the fluorescent marker. So that's what we've achieved at 600 litres a hectare with the water. This is Elasto G5 at 0.25% volume, and this is the kind of a coverage we've achieved. We've got a very nice spread. Now, organosilicon adjuvants are out there and available, and they have proved to be effective in some situations. But this is the comparison. This is what we're looking at. With an organosilicon, you are moving liquid quickly. So what we've got here is these kind of coffee cup rings around the outside where it is sat there. That is what we're trying to avoid by using a high quality adjuvant such as Elasto. So a few more images. Let me go back to that one. 400 litres a hectare with no adjuvant and 1,000 litres a hectare with no adjuvant. Water volume is critical. The lower we can get that water volume, or the closer we can get it around 400, assuming we are hitting a standard plant in a normal situation, the better. And you can see what we've achieved there. We've got very poor coverage with the 400 litres no adjuvant, and when we've gone up to 1,000, what we've got is a lot of runoff. So we've got a lot of liquid that's kind of accumulating around the edges, and it's running off and highly likely to be dripping off. We'll have a little look at that later. But with the 400 litres a hectare of Elasto G5, you can see we've got excellent coverage. We've got a little bit starting to congregate about the edge, but nowhere near as much as we have over here. Excellent widespread coverage, and even at 1,000 litres a hectare we've managed to do a better job, higher than we would want that 1,000 litres a hectare. We were looking to get it down to this kind of coverage. So we got a ficus leaf here, very difficult to wet. These are 400 litres a hectare on the left hand side with no adjuvant, 1,000 litres a hectare with no adjuvant. You can see the run that we've got there. And you can see how much the better the binding qualities are when we add the Elasto G5 in. Even at 1,000 litres a hectare, we've got some really good stick, but we're trying to push it into this 400 litres a hectare region. Worth getting your spray rig set up properly for that so we can achieve that kind of coverage. And what's going on? So what we're looking for is low dynamic surface tension rather than high dynamic surface tension. What that's doing is enabling the liquid to stick to the leaf when it hits it rather than shatter and bounce off. And we tend to correlate retention to a dynamic surface tension at the surface of around 100 ms. Now, that's the work we've done with our engineers to try and get this there. We're looking to get this to stick to the leaf. And we've done it. We've done some really nice work. We've got water here at 1,500 litres a hectare. And then we've got another organosilicate type product in there at 1,500. And then we've got the Elasto at the end. And you can see we are sticking it to the leaf rather than allowing it to run off. You can see in that middle image how much of it has run into those veins in the leaf and disappeared off. And it's worth looking at the back on these images, because you can see with this organosilicate type product, we've got this dripping around the edges. We have nowhere near that amount going on with the Elasto. With the water by itself, we've just got a lot of bounce off and a lot less of it there. Whereas with the Elasto, we're sticking it to the leaf and it's staying where we want it. This is what we're trying to avoid here, these runs, because this is all running off and disappearing away and not staying where we want it. More image and retention, improved retention and coverage. You can see here that the Elasto, which is this one in here, you can see how good the coverage across there is, rather than some of these other ones where we're getting it run to the bottom and the underside and stick. The other good one in here is Assist M36, which is an adjuvant that we're working on to bring to market later on, maybe next year. But this is an organosilicate. You can see all the run you're getting down to the edges and how it's running underneath the leaf. It's not getting where we want it. And again, more kind of the science behind what's going on there. We have dyed this droplet with black dye, and you can see in the top 5 minutes after treatment, both are still sitting there on the leaf. But 3 hours after treatment, you can see how the water has dried out. It's kind of shrunk down and stuck to the leaf in a tiny dot. Whereas with the Elasto, we get this much better spreading over the leaf, which allows us to pin the product to where we want it. These things are allowing us to get more of that active ingredient on top of the leaf, spread evenly, so it gets taken up and we get more out of our products. Improve the leaf surface contact over time is exactly what we're trying to do. The leaf surface is designed to not let liquids get in or out. That middle image shows the Minazide, which is a plant growth regulator without Elasto in there, and you can see how the crystals are very large. Yet when we've added Elasto in there at 0.25% of the water volume, you can see how we've broken it down and we've spread it much better. To improve leaf area contact results in a higher uptake of that active ingredient. It's allowing us to get more out of these products. Now we can look at that as one of two ways. Either we can lower the rates, or something like a plant growth regulator, we can get the same effect as we would by using lower rates because we're pinning it better to that leaf, or with something like an insecticide or a fungicide or even some biocontrol products, we're spreading it much better over that leaf to get more efficacy out of it. So avoiding runoff, this is one of the key things we want to talk about. So this is an application trial in Gerbera in 2019, and you can see, looking at these three images, the first one is just water, and you can see underneath it's quite difficult to pick out, but here we have all of these white kind of UV lights. This is droplets where spray or liquid has bounced off the leaf and it's bounced onto the floor and the black light has picked it up. We've got far less in this image where the elasto's gone on, but where we used an organosilicate type product in this one and we've run off to the edges, you can see all of the drips around the outside of the plant where it's been lost to the floor. Now all of this product is getting somewhere we don't want it, and it is not doing the job that we want it on the plant. So there you go, water, Elasto G5 and an organosilicate. So we've done lots of trials to support this. Here's a nice one that we did, and I got involved in this one. It was good to see it in action. 500 litres a hectare in the first half of the trial using Guardian Air 025 nozzles. The second one here is 0.25% Elasto. And what we did is we sprayed this clematis, and then we took it back to the lab and we analysed all the plants, and this was on average the amount of spray deposition we were finding between those two. So same water volumes, there was a active ingredient in there that we were analysing afterwards, and we were seeing around 650 in here, but yeah, adding the Elasto was binding it to the leaf much better, and we were seeing over twice as much stuck to the plant. Then we did the same trial at 1,000 litres a hectare here by going up a nozzle size to the 0.5s and adding the Elasto in, and we saw a similar trend. You know, we saw an improved response by going up to the by adding the Elasto in. But what's interesting for me is this 500, just like I was talking about earlier, reducing those water volumes is showing more deposition on the leaf. So from a safety point of view, which is critical, it is very crop safe. So we've never seen any phytotoxicity ever in any trial. In more than 18 years experience, we've been using it around Europe for a while now. No adverse effects in ornamentals have ever been seen. The images you've got there are untreated normal doses, 2.5 litres and triple dosing. We've never seen any adverse effects from the Elasto. It is worth mentioning though that because we are getting more active ingredient into the leaf, we do open up the opportunity, very rare do we see it, but the opportunity to cause some issues there. So just something to be aware of. We are making products more effective by adding this adjuvant in, so you want to be aware of what you're putting in the tank and just be aware of the additional uplift of more product getting there. It's IPM Fit. This is great news. So we've got an IPM Compatibility trial here. We've got an insecticide to start just to show what's going on. So number of mites, day of treatment, day of application was around the 25 all through all three products. With the insecticide, we have indeed knocked down the number of mites to a low level, as you would expect with an insecticide. With the Elasto G5 at 0.25%, we have maintained the same amount, and then we've moved up a little, and we've seen very, very similar results with the 0.75, so 3 times the application rate. And we've seen no downturn on the number of mites. So IPM Fit will fit into those strategies very nicely. Now, Elasto G5 is a great partner for hydrophilic active ingredients. Hydrophilic is products that have a strong affinity to water. Hydrophilic molecules tend to be dissolved in water. So you can tell that by looking at the log P. There is no downside to using it with others. It is more effective on those. And as we're working on other adjuvants that are going to work better with lipophilic products, we will give you more information about that as we launch it. So there's no downside to tank mixing it with lipophilics, just we get much better response when we do it with the hydrophilics. Just something to be aware of. So PGRs, plant growth regulators, these are a really good way to explain the benefits of this product. So what we're looking at here is chlormequat combined with Elasto, and you can see in this left-hand chart here, this is after 2 treatments in here. So the 4 treatments we've got here, this is untreated in yellow, then we have 0.5 litres a hectare in here, and then we have 0.25 litres in here, so half rate, and then 0.25 with Elasto. So at this stage, the lower rates are all, this is right after, early on in it, and this is the height in centimetres, so sitting around 11 centimetres there. So what we've achieved there is a better level of plant growth regulation by this half rate with the Elasto than we have by the chlormequat at full rate itself. So again, by spreading that active ingredient over the leaf well, what we've done is taken this rate, spread it over the leaf very well, and improved the efficacy over the full rate. And after 4 treatments, we've seen a similar pattern. So this is the untreated, this is the full rate, this is the half rate, and this is the half rate plus Elasto. So a better result there again than the full rate. And this is really useful because it just demonstrates how much better we combine these active ingredients to the leaf when using the right adjuvants, and shows the better efficacy out of it. And here's some images from that trial. You can see the untreated there with this nice line across here to show the untreated. Same line across all of them. So this is the full rate. You can see what we've achieved there. This is the half rate. You can see what we've achieved there. And then this is the half rate with the Elasto. And you can see we've got very similar levels of control to the full rate, which is great news. Lower doses of PGRs in Sophinia. And what we have here is height in centimetres down this left-hand axis. 200 grams of diminizide here, 100 grams of diminizide here. So you can see between these two, we have got higher levels of control with the 200 grams with the higher rate. By adding 100 grams to the Elasto, we have improved the levels of plant growth regulation, so we've brought it down. Now, what was interesting in this one is we used this same rate with an organosilicate, and actually we saw a reduced performance. There was less. So again, if we think back to those images where we're running this product off the leaf, if we're using the wrong type of adjuvant, we had less active ingredients, so therefore less effectiveness. And the untreated, this is where we were. So they all worked, they all did something, but we managed to squeeze the same or improved levels of control with diminizide by using the adjuvant in that one. But it's not just about height, it's about diameter as well. So in this one we've got the diminizide and we've got the diameter in centimetres down this side of the axis. So similar story again, 200 gram rate, 100 gram rate, obviously a lot wider. 100 gram plus Elasto was getting closer to this 200 rate. If we use the diminizide and organic silicon in this one, then improved in this situation, but all compared to the untreated, not good. So by lowering the rate using an adjuvant, we have an opportunity to get more active ingredient to the plant where we want it and make more out of those plant growth regulators. Performance with bioinsecticides and fungicides. So what I've got here is a trial that we've done looking at a combination with hydrophilic ingredients in insecticides. So this is pymetrozine and pymetrozine plus Elasto. The yellow one is the pymetrozine and this one is plus the Elasto. And you can see 7 days after treatment 1, we've got a 38% improvement in the percentage control. 7 days after treatment 2, we've got a 24% increase. 6 days after treatment 3, 15%, and 12 days after treatment 3, 33%. So by adding the adjuvant in with that product, we are getting this where we want it, giving ourselves faster efficacy and longer residual effect. Bioinsecticides is another interesting one. So this is Bacillus thuringiensis, and which I'm going to refer to as BT because I'm rubbish at saying that. So BT, we have 6 days after treatment 1 here with just the BT, 3 days after treatment 2 in the red, and 7 days after treatment 2 here. Now by adding the Elasto in, we get a very impressive initial uptake with this biocontrol. We then see strong holding on to that throughout the trial. So again, get the right adjuvant on, get these things in the right place. We see a big step forward. Here's another trial looking at the same kind of thing. We're looking at percentage control here. So by using the BT in yellow, we see an improvement in control with the Elasto. Same as 6 days after treatment 2 and 7 days after treatment 3. If we look at, so that's control of caterpillars, if we look at percentage damage, and we can see we have reduced the amount of damage we are seeing by using the Elasto. So all good news, getting things in the right place. Contact fungicides is a useful one as well. Again, contact fungicides are all about getting the active ingredient in the right place. And what we have here is switch at 0.8 kilograms a hectare. And the orange line, we've got the Elasto in there by itself, which is showing percentage control. So just by putting Elasto in alone does not give us significant levels of control. Switch by itself, as you would expect, very good levels of control. We're up to kind of 60% here. But by putting switch and Elasto in, we've improved the efficacy because we're binding more of it where we want it. And we've got around 75% control of botrytis in this trial. And there we go, you can see some images from this one, untreated, very unsightly. Switch by itself, we've moved it on dramatically, but there's still evidence of damage, and the switch and Elasto G5 looking very good. So we're improving coverage of contact fungicides and therefore improving efficacy. Elasto G5 is also the ideal adjuvant for biofungicides. So what we've got here is a Topaz Tegro program put together. In this left-hand side, we have Topaz and Tegro, and then on this right-hand side, we've got Topaz and then Tegro plus Elasto. Timings were treatment A was the Topaz, and then B, C, D, E, and F was the Tegro, which is a Bacillus product. And then in this side, we've got Tegro plus the Elasto. So this wasn't really to look at how effective the bio fungicide program was, although we got some very good results by the program by itself. This was to see what improvements we could make by adding the adjuvant. And we're kind of sitting in the 40 to 50 range all the way through this trial, whereas we have lifted that up to the 70 to 80 range by adding in the Elasto. Again, adjuvants getting products in the right place. This one's in cucumber, so useful to know because we've got a similar kind of leaf structure, and we have 4 days after treatment G and 9 days after treatment G in this one. This is the going forward, so this is check, this is no treatment at all, and then we have a fungicide to start with, and then into Tegro, but simply by adding the Elasto in, we have improved the level of pest severity. We reduced it by, so the level of control, pest severity has reduced. Using Tegro again, we've got higher levels of damage than using the insecticide, but we have improved it dramatically by adding that Elasto G5 in there. So getting this in the right place. And there you go, we can see what we've done with the images. We've achieved some very good levels of control with the biofungicide and Elasto G5. Biostimulants are another thing that are worth looking at. As we increasingly look at biostimulants, what we're trying to do is get these things in the right place. HiCure is an amino acid based product. As the plant goes into stress, it can't produce its amino acids as well as we would like by itself. So we want to deliver free amino acids to that plant, and we want them to be foliar absorbed. Now what we have here, we have really used HiCure to reduce the plant stress, which has therefore reduced the opportunity for disease to impact. In the untreated check, you can see we've got a high level of disease incidence kicking off. We're reaching 90 or 85% by the end of this trial. By using HiCure by itself, you could see that we don't really have an impact with HiCure by itself. So we have on 7 days after treatment B, we have got a reasonable level of control compared to the untreated check, but quite quickly we bounce back to a similar area. By using it with Elasto, we start really improving that plant health, which helps it reduce the opportunity for the powdery mildew in this situation to take over. Now we also used an organosilicon in this situation, and we saw similar results. Not as good results, but we did see similar results by spreading it on the leaf and getting it there. But by spreading it and sticking it with the Elasto, we saw some very positive results. It's best combined with those hydrophilic active ingredients. Like I said, there's no downside to using it with lipophilics, but we are working on an adjuvant that is going to work with those and improve the efficacy of those more too. So this is dicamba and then dicamba and Elasto, looking at a number of different challenges and weeds. And you can see by using the dicamba and the Elasto, this is the half rate. So we've got full rate here of dicamba, half rate here. So full rate, half rate, and then half rate plus Elasto. The percentage control 7 days after treatment is pretty impressive. If we look at what we got going on, full rate, so full rate here, half rate, and half rate plus Elasto. You can see all the way through, you see very similar trends whereby adding the Elasto in with the dicamba, we kind of either outcompete or do better than the product full rate without it. So compatibility, we have a wide range of compatibilities. With this one, no issues from all the things that we've tested. Very good news, great tank mixer for all formulations. Really helps with the uptake of AI. There's a whole list, best to talk to the ICL team for exact advice. Here's some of the ones that we've done some research on. As we get more data, we will share it with you, and as we look to launch more adjuvants in the future, we'll of course help you with your decision making about which ones are best with which. It's great with hydrophilic active ingredients, very, very good with contact active ingredients. Biologicals really enhances those, very good with plant enhancers, excellent to help out in difficult conditions, and brilliant for tank mixes. Use Elasto in a concentration of 250 millilitres per 100 litres at 0.25% of the tank. Okay, it's crop safe, it's IPM safe, it's an adjuvant. Improved uptake of active ingredients, improved coverage, improved retention, and reduced risk of runoff. It really is a great product to help us out. It doesn't replace good application. We need to do good application and get some adjuvants in there as well. It helps us reduce those rates of those plant growth regulators, but it will also help us get more out of insecticides, fungicides, and biocontrols. Thank you for listening. I've been Glenn Kirby, Technical Manager for Syngenta. If you've got any more questions, please get in touch with me or the ICL team, and we'll be more than happy to help.